We exist in an infinite universe, full of more mysteries than we can conceive, stretching beyond our imaginations, constantly unfolding. From solar systems to nebulae, from nebulae to galaxies, from galaxies to superclusters, everything is connected. So what happens when there's a break in the rhythm of the universe, with nothing but emptiness left in its place? What is the mystery of this great void in the cosmos? An enigma that has left the world of science stunned for decades. The story of the Boötes void is really just the story of humanity's tireless efforts to make sense of the universe we exist in. While different societies had been studying the stars for thousands of years, the science of it only started to gain momentum at the start of the 19th century. For the first time ever, we had access to photography, finally making it possible to track and analyze the data we were getting from space. Combined with the development of more powerful techniques and equipment for space exploration, we were now able to see more of our universe in ways we could never have imagined. Humanity was able to explore the universe beyond the Milky Way for the first time ever, and discoveries followed at a staggering rate, each one hammering away at our previous conceptions. As an example, before astronomers started mapping out the universe a few decades ago, the consensus in the scientific community was that everything was more or less homogeneous in the cosmos. In their view, if you looked out far enough, all the different celestial bodies would start to even out, and things would look uniform. That made sense for the time. The cosmic microwave background, electromagnetic radiation emitted 380,000 years after the Big Bang, was homogeneous. This suggested the universe was uniform around the time of the Big Bang, and even though that was 14 billion years, scientists just assumed the modern universe would still have a similar structure. The first hole was poked in this assumption when Lard A. Thompson and Stephen A. Gregory found evidence supporting the existence of cosmic voids in 1978. However, it would be completely shattered in 1981 with the discovery of the Boötes void. For a while, cosmic voids were still believed to be anomalies. That was until 1986, when a team of Harvard scientists surveyed space and discovered they were everywhere. With more in-depth research and the development of technology that could map out the universe in detail, scientists began to get a better sense of cosmic voids, and in turn, the universe. That brings to what we know now about the universe, and that is, its structure is extremely intricate. As a visual, it's kind of like a massive spider's nest made up of countless cosmic webs, which you could say are its building blocks. Cosmic webs are these incredibly large, incredibly complex networks of dark matter, gas, and galaxies. They are formed from interconnected filaments of galaxy clusters, and essentially give the universe its structure. Understand that cosmic voids are just as much an essential part of the cosmos as their populated counterparts. In between these webs, there are huge expanses of mostly empty space. These are cosmic voids, sometimes referred to as the deserts of space. Not just that, they also made up the majority of the observable universe, at about 80%. In essence, cosmic voids are a core part of the balance of the universe, much-needed gaps in the stitching of its fabric. Let's refer back to the Boötes void, or the Great Nothing, like it's sometimes called. As we previously mentioned, it was discovered by Robert Kirshner in 1981, while he and his team were in the process of creating a map of the universe. It is a spherical void that just happens to fall in the Boötes constellation, hence the name. The Boötes void did not get its name from its shape. People often confuse it with Bernard E8, a boot-shaped space void. The Boötes void is the largest cosmic void in the visible universe. To give you an idea of its size, it's approximately 330 million light-years across. That's over 2% of the visible universe. It is a vast cosmic wasteland, with only 60 galaxies discovered so far in an area that should have at least 2,000. The average distance between the galaxies in the void is around 10 million light-years, so any galaxy unfortunate enough to be located in it would be extremely isolated. Just to break that down, in the words of astronomer Greg Ordering, if the Milky Way was located in the Boötes void, it is very unlikely that we would have found out about the existence of other galaxies until the 1960s. We would have really dark night skies with very little in the way of stars. Scientists currently aren't sure how space voids are created. Even if we were certain, the existence of a void as vast as Boötes would pose a unique problem. The Boötes void is larger than our current understanding of galaxy formation and cosmic large-scale structures permits, and this creates a bit of a mystery. The generally accepted explanation for space voids is that they were formed right from the Big Bang, existing then as a tiny spot of decreased density that exploded in a release of energy that stretched the fabric of space itself, an event known as cosmic inflation. This is the most popular theory among scientists for the formation of voids. It's intuitive and is backed by a ton of supporting evidence. As an example, particles in the Boötes void have a much lower density than anywhere else in the observable universe. There are several theories attempting to explain its existence, but none have been proven so far. The most convincing says it was probably the result of several smaller voids merging together to form one huge supervoid, kind of like smaller soap bubbles coming together to form one giant soap bubble. Astronomers studying the void arrived at this answer by analysing the arrangement of the 60 known galaxies in the void, observing that they were all organised in a tube-like formation near its centre. They concluded that this was most likely the result of two large voids that merged into a massive one. Another popular theory is that the universe was more like a tightly packed uniform soup, but as it expanded, gravity pulled galaxies towards other galaxies, forming clusters, leaving larger and larger voids in their wake. While supercomputer models support this theory, a lot of scientists disagree with it, at least when it comes to the Boötes void. In their view, there's not been enough time since the Big Bang for a void this size to have formed. Overall, scientists still generally agree that voids are a result of the Big Bang, including the Boötes void. This final theory is mostly popular among non-scientists, but it is also widely believed that the Boötes void is so desolate because it's packed with dark matter. But most scientists agree that the void is just that. Void. Void of dark matter, regular matter, or matter of any kind. But beyond figuring them out, why are cosmic voids so important to astronomers, especially voids as massive as the Great Nothing? Well, a lot of scientists currently believe cosmic voids are the most intact relics of the evolution of the universe, from the Big Bang to its gradual expansion over billions of years. The chaos of cosmic webs makes them way too difficult to study and makes deducing their origins impossible. On the other hand, cosmic voids are much quieter and far less disturbed by the interactions of space, kind of like cosmic fossils. By studying them, scientists help to solve some of the universe's greatest mysteries, like the universe's rate of expansion, dark matter, and dark energy. Research like this wasn't possible until very recently with the development of supercomputers. With these powerful machines, capable of making trillions of calculations per second, we can map out and create more accurate models, creating the potential for more groundbreaking discoveries. Still on the topic of space voids, two recent studies suggest we might be living in one. Yeah, that's right. This was first proposed in a 2013 study where University of Wisconsin astronomer Amy Barger and then student Ryan Keenan found that the Milky Way possibly resides in a void itself. And now, a new study has caught the eyes of the scientific community that not only supports the idea that we exist in a cosmic void, but also opens up the possibility of accurately determining the age of the universe. The void proposed to contain the Milky Way is the KBC void, named after the initials of the scientist that discovered it, and is about 1 billion light-years in radius, possibly making it the largest cosmic void in the known universe. In the scenario the study presents, the Milky Way is at the center of this void, and the void is not completely empty, rather just 20% less dense than the universe on average. The nearest confirmed void to our galaxy is called the local void, and is found near the end of our galactic cluster, stretching across a humongous 200 million light-year radius. Most of the known universe is made of cosmic voids. Scientists believe they are the key to unlocking some of its most important secrets. Of all the countless cosmic voids in the known universe, the Boötes void is one of the most challenging to study, but it is also one of the most promising. As scientists are working round the clock to crack its secrets, and in turn, the secrets of the universe, we can only watch with bated breath.